Tong has the first item on the agenda, but he's not here yet. How's everybody doing?
Hello, sorry. Okay, looks like the first agenda. So I'm just wondering if do we know what CNG Omnibus or Infra need to unblock them? Because I think specifically we're talking Infra here because I know CNG or Omnibus have not started.
So about infra, what I can update everyone is that we got the approval to get the data from production to restore in the benchmark environment. I raised a couple of things we need to adapt for our test, but yeah, now we are not blocked. I need to work with the infra team to add the components that we need. The main thing I want to clarify here, that's my topic, the second one on the agenda, is about the PG bouncer structure. Let me quickly explain. In .com, nowadays we have just one database, as everyone knows, and we have two PG bouncer pools. One in transaction mode, that's for web API, and another one for a sidekick traffic that is in session mode. My question is, like I was talking briefly with like Dylan last week, and we thought about to have like two pools for the CI/CD as well. Would that make sense, or we just need one of them?
I think we talked about it, but I still wasn't quite clear when we chatted about it the other day what the point of these were. There is supposedly some different PG bouncer configurations that make more sense for Sidekick, and then some that make more sense for Web API. And if that's the case, then I think we need them both for the CI database when we get to production, because that's going to be running in Sidekick and Web API. Is there any other considerations that would change that rather than us just mirroring exactly the same database setup that we have today?
Well, just I have one more question here. Is like the point with the read-onlys, because nowadays, as I explained in one issue today, our read-onlys, we have 3 instances for PG Bouncer, and we have the both pools there. I will keep the same in CI/CD, okay? So if you, like what I see here is like, you will change your configuration, just not in 2 points, like the 2 endpoints that you have nowadays. What you have for CI/CD, sorry, for the regular, today the application uses two different DNS names or two databases, Sidekick and Web API. You will have the same thing for CI. You will have CI API and CI Sidekick, let's say.
I don't know how it's configured in production today, but my understanding is we would only have a place for you to configure a single database URL in the GitLab application. So if it's different...
Exactly. This is the point. Like when you use the Omnibus, yes, you have just one point. You're totally right. But for .com, we have this duplicated. We have one for Sidekick and one for the other applications.
I'm guessing the way that you're doing that is that you're doing it on the Sidekick nodes. You're just configuring them with a different host name there. Yeah. So I mean, nothing in the application really understands these different pools, but if they're necessary for the workloads that we're running to be efficient, then that seems we'd just keep those. But yeah, the application itself doesn't need to support this because you just give us the URL that's relevant for the correct host.
But wait, but Sidekick is part of the application or not? Because we have a different one there. Or how you consider
it is, but you're deploying Sidekick on different servers and then configuring it differently in Chef or an Omnibus or wherever these are being configured, right? So the application doesn't understand that Sidekick has a different database connection, because in GitLab.com, Sidekick just runs on different servers with a different configuration. I'm assuming that's how it's working today, but.
Okay, I will follow up with infra to be 100% sure on this. The second part here is like with the read-only that I will keep the same as we spoke. And the third part or third point I want to mention, I didn't add in the agenda, is the how to execute this failover fast. I think all of us understood what we are attempting to do, stopping the traffic, redirecting the PG bouncers that has the CI traffic to the new Sharding database, stop the traffic, promote this database, redirect the traffic, shortly talking. The only point I want to do this like in the fastest way possible. And nowadays we have Chef that sometimes to apply configurations takes quite a reasonable amount of time. And I'm trying to investigate with our colleagues in infra how to make this in the most smooth way. Before I have done applying like as we spoke, like apply directly the configurations in the host with Ansible. But later on, when we enable Chef, we have a drift from production, and this can have like some nasty side effects. So I'm trying to avoid like what we have seen in the last upgrades. As soon as I have this more clarified, I will bring here.
So the problem is like how we can like change PG bouncer configuration quickly to kind of like restart that and like apply, let's say, like the new servers that it's writing to, right? This is also what you're asking.
Yes, I had some problems to apply configurations in this level or in the database host, and sometimes Chef took me like 5 minutes. In this, if we do directly in the host, we can do in like 10 seconds. So I'm trying to force this to happen faster. Perhaps have the configuration already deployed in Chef, have the Chef client stop it, and during our maintenance, execute this to refresh the configuration. And with that, make it like in 1 minute or so.
So like how many like PG bouncer nodes we would be looking at, like reconfiguring? It would be 2 or more. I think likely more, right?
Yes, we have nowadays the read writes. If we're talking about read write, that is the most painful. We're talking about 6 hosts at the moment. We have 2 nodes, 2 clusters of 3 nodes. And after every one of our read-onlys has 3 nodes for read-only traffic.
Yeah, the read-only traffic ones run on the same host as Postgres, so they don't need to change. Yeah. They won't be reconfigured as part of this.
It will, because like you are moving your CI traffic to new hosts, right? Let's say the old hosts or
not read-only traffic won't be changing live. So because the read-only nodes are just replicas of the same database, we don't need to do any live cutover for them. They're just, we will already be reading from the correct CI databases ahead of time. And the way that will work is you'll have the host name for the Petroni replicas. All the replicas will be configured for CI ahead of time. We don't have to change those PG bouncers. Plus, we wouldn't want to be redirecting PG bouncers outside of their own host for read-only.
Okay. Please, just to repeat, you are telling me that you will configure the CI application to be using the read-only just already in the cluster of CI. So you are reading, okay, perfect.
So then it's only the read-write hosts, and I'm unsure how many of those we have or need to have, but yeah, that's the thing that'll need to be reconfigured.
So this is like I think like the challenge of the coordination, because like we need to stop read-write traffic on the CI on the pure. We need to promote database hosts to be like authoritative. So kind of also disconnect like streaming replication from the main. And then we need to like reconfigure PG bouncer to write to the new.
Exactly.
This is exactly what we need to do. So like it's kind of like the coordination that we need to like. We need to probably stop PG bouncer, promote, and then restart PG bouncer and assume that everything's gonna work, right?
Yes.
Yeah. PG
like if you do this
pause feature, but we need a way to reconfigure, and it's only configured via config file, which is basically means to say that we're going to have to edit the file live.
I did. Sorry, Dylan. So what I did is something similar, is like doing our upgrade, is promoting a clustering cascade as we will have here. Like this is a command inside of a Patroni, so it's like this will not make our life so hard. This will promote quickly that the action itself is fast. My only concern is how to update this in PG Bouncer to be applied quickly, the rerouting to this new cluster.
Yeah, my hope, and what I documented, my hope is based on using a CNAME record and PG Bouncer detecting that that CNAME record changes within 2 seconds when it runs its next DNS resolution. But I just actually don't know how to do that because all my testing, it just doesn't work for various reasons I wrote down. But I still think that DNS, if we can work with somebody who understands maybe our infrastructure, how our DNS is configured there and what places we might be able to stick a DNS record that will actually get read by PG Bouncer. If we can manipulate that live, I think it'll be the fastest way because PG Bouncer doesn't even need to be told to reload a config file. But
yes, but like with DNS is tricky because you might have cache on DNS on many levels, and like you may not really have like the sub-second like response time. I'm kind of like, at least in my head, DNS, like the lowest resolution that you can get reliably is like 60 seconds. This is like in my head from the DNS. With
well,
etc, like we may make it force like to be much more robust if you point DNS resolver right into etcd. But I'm not sure like if we can achieve like seconds accuracy.
yeah, it's how our failovers currently work for our replicas to become masters today in our live pre-training cluster, and it's meant to be on the scale of 2 seconds.
Yeah, or TTL is low. Yeah. My understanding is like our TTL in production is pretty low. I will double check this. I will raise your point with the CNAME. And
but in
start
any
to,
case, I mean, Camille's right in that like we could theoretically be faster than 2 seconds if PG Bouncer can pause and reload a config file in 100 milliseconds, then we can be
You can
faster.
reload it quickly, so that should be quick reloading the config file. It's a simple command on the PG Bouncer console. After
Yeah, so
that,
if PG Bouncer pause, reload, resume can happen in 100 milliseconds, then it's probably better than using DNS. We just need a way to manipulate the config file that isn't hacky, but basically pretty much the only logical option is we have a command that SSHs into all of our PG Bouncer hosts, edits the file, well, runs those 3 steps, pause, edit, reload. Seems like the only logical way to do it, but yeah, depending on how many hosts that is, that may not be super fast. If you had centralized single place to change a DNS record, then you kind of simplify that process a little bit, but it could be slower still.
So I'm kind of thinking like, I didn't follow like recent discussion, like how are we gonna make the authoritative switch on the database rights? How long it's gonna take compared to the PG Bouncer?
We have to benchmark that. How long is it going to take to make the switch? Well, theoretically, it could be very brief because we believe that streaming replication is usually like within a couple of seconds. We need to stop writes, which we talked about separately as like disconnecting PG Bouncer through some way of blocking it, or the pause command in PG Bouncer. Then you need to just check the streaming replication catches up to the point where the last transaction you were at after you paused it, which should not be theoretically more than a couple of seconds if we're pretty well up to date with streaming replication. Then we start.
I'm asking because like it kind of like, I think it's under slightly perspective, like if it takes like say 10, 15, 20 seconds, it's under perspective how much like PG Bouncer can take, because like it's like if it takes like quite amount of time, it's not gonna be like failover approach that's gonna be like immediate, almost immediate. So maybe we are kind of like then aiming for the wrong goal of like making these like a few milliseconds of downtime where like it's simply not feasible to achieve that reliably. So I'm kind of like thinking that like if we can estimate like the worst case scenario for this switchover of the writes, and for the PG Bouncer, it's gonna give us like, if it's like 10 seconds, 30 minutes or 5 minutes or whatever else, and what we are like kind of looking at. Because then like if it's actually like if we are looking at 1 minute, like I think also like what we can do and like how we should approach also changes like what tooling and how robust it needs to be. And maybe like it simply says that like it's not feasible to achieve like say 30 seconds like failover reliably on the live running system, and we need to kind of like accommodate slightly more to have this headroom.
I think we will have a good experience or timing experience when we execute this in the benchmark environment. We are simulating traffic from production. So the database will be with a load already of 20, 30 points of CPU utilization. And we will have metrics to see this after the first attempts.
Is this performance benchmarking also test like CI stuff? I mean,
I'm simulating traffic. Yeah, I will explain. What I'm doing here currently, like we took like the queries that are taking most time to be resolved and the most executed queries. This is the workloads that we have. Nowadays, I'm asking to split the traffic for what is CI related and non-CI related for us to exactly simulate this on the speedy bouncer level. Okay. This is the attempt today. And what Dylan said as well, that is right. If we will apply this when we have low database peak time, like the replication lag is seconds, you know. And I believe that with the pause, because we are updating configuration and so on, there is a chance that we will have some hiccup on the application, like we will return some errors. But I believe that we are in the, like I need to test, we're in the house of seconds. Not a minute, but let's prove.
Okay. Yes, I think we need to test that. Maybe like, I'm just unsure like if we are ready to test that now. Because like in on average, like our application, like it's probably somewhere closer between like 100 to 500 milliseconds, with peaks being significantly larger when there is like a lot of writes. But I'm not sure. I think we need to test it.
Yeah, which kind of comes back to Tom's question originally, which I expect he wants to take in a slightly different direction. But from this perspective, like for infra, I think everything is that like we need to do next in terms of benchmarking doesn't really require anything from the application. But then the next logical thing is the application, when we get to deploying all this infrastructure and having this separate database cluster, the first thing that we're going to want to be able to deploy is read workloads to go to a separate database for CI. So that would be stuff that we're already working on, I think. That'll be the logical thing before we can ship something to production. I think we'll have at some point, we have a second CI database cluster in production that is a replica, and we want to just configure GitLab's reads to go to that. That will be, and that's through the load balancing code today. So whatever goes through the load balancing code resolves the DNS records. We want that to be able to support a separate host name for reads for the CI application record, CI tables, and then that will be able to ship something to production.
Yes, but I think like there is like this catch related to two different connections. If you start, let's say, because like from what I'm kind of hearing, Dylan, like you want to configure two connections, both of them doing writes to the same database, but these are two distinct connections still, right?
Well, that's a different.
Yes.
Writes can come later. I think like first step is reads, but yeah, like and writes are configured to use a different way of getting a connection today in GitLab. They don't use they do use the database load balancing code, but
I'm like in particular like worried about like the case that we have two distinct connections to the same logical database, and we also have to resolve two-phase commits in that, because like redirecting reads only, I think we are not like the current code is not really like well prepared to redirect only reads, but maybe
Well, I think all of these things are prerequisites. So if you take a step back, then the application needs to stop using joins. The application needs to have a consistent model of how it creates transactions so that data isn't transacted against two different databases in a way where that would lead to really bad inconsistency problems. The database just needs to be resilient against that. So like there's a stack of application changes that go before actually shipping that. I mean, I would hope we could maybe separate the read part of this and deploy that earlier, but it depends on how tangled that is with the rest of the code. Because
I mean, like, it's not really that. It's not that like we have to solve all of these aspects yet, because with the streaming replication, we would be replicating all tables as well. So technically, like we all have all data for make all our joins to continue working today.
Yes, but after your failover, you know that you will break the stream replication, no? When you
Yes,
promote
like,
your
yes, but like this would come later, right? But like we can embrace like testing this cluster that like it can handle reads with just like knowing that these joins are happening today, and like kind of work on issues to like break these joins to not like cross join other tables.
yeah, we could certainly talk about sequencing that, but I think we don't want to get the application thinking that it can query. Like we don't want to get the application in this inconsistent state where it thinks it can run joins that it shouldn't, especially if we've got two different structure SQL files and in the GDK set up locally is all such that they're two separate databases. They don't actually have all the same tables and they're not replicated. We don't really want to get the application into a state where it's actually executing queries that are kind of inconsistent with the structure files we have. So like the fact that we're going to do this in production with this streaming replication and having these identical, I don't think we ever want the application to really rely on that. And certainly not for a long period of time. That just seems like the code will be in a weird state. There's not really much advantage to getting that out early.
Great. So just to clarify, we need this for benchmarking or production. They're two different things.
Well, benchmarking, we don't need anything. That's what we're about to do. I think I think there shouldn't be anything in the application needs, and especially because we weren't going to use application code in the benchmarking. That the SQL queries are happening through JMeter, and we're going to be testing things at the infrastructure layer.
Can we,
Yeah.
because like we work on the POC, it's getting, I saw that Tonk is getting pretty green. Can we like build omnibus package and CNG package out of this POC and like use that for the benchmarking?
We have big problems here with security. I originally thought that we have the code developed in the application as well, or part of this failover strategy. And when I start to dig with SREs, like the environment is not sealed, and we are hundreds of concerns about like if we call some webhook outside, you know, because we will have production data on this database. And there is some security reasons that the people is like being really concerned.
Can we block all egress traffic?
I have a thread with a long discussion. I will add you there, Camille, and you add your thoughts there, and we discuss with folks. SREs are thinking that this will be a lot of work. I believe that it's possible, to be honest, but I need more support there to get this done.
I mean, like, because like in any world, when we start running like our code against production data, we need to block egress traffic and like block as much of incoming traffic as well to ensure that we don't leak outside. So I kind of considering this like really like prerequisite for all our work related to running application.
There was different discussions in there about potentially not using real production data and anonymized production data, but there's two different goals. That doesn't work for benchmarking, but it does work for us testing the application. But
I will add you guys to the threads, no worries.
Jose, can you like send me a link later to this discussion about the ends?
Yeah, I will add you the notes
about like the findings there.
Yeah, well, the next step, I think, to just like summarize on that, the next step for the benchmarking was we don't need to deploy the application, and we don't want to for those security reasons for now. But yeah, back to Tom's question about like what to do next to unblock people. I think it is probably a relevant discussion point for us to figure out like what configuration we need in GitLab, what it needs to support for the work to happen concurrently from other teams. Like I think probably CNG and Omnibus seem logical to me. Like, how does the configuration API of GitLab need to change, or is the YAML syntax we've already got, is that enough for them to start working concurrently?
I'm kind of like, I noticed that like right now Omnibus and CNG is scheduled pretty far. It's like 2 milestones from now. And I'm actually asking if this can be speed up, because I think it's gonna be a bottleneck for your work, Dylan, and your Jose work if it's come that late. Because like Omnibus is scheduled like in 2 releases from now, CNG is scheduled 3 releases from now. So it's pretty late, I think, in the timeline. And I think we need this earlier to be done. Do you agree or disagree with me?
I agree it would be helpful to get it done earlier. I don't feel blocked on answering the question about how this streaming replication is going to work. That's like, God, that's kind of the top of my mind right now, is how is the streaming replication going to work? What is the actual latency going to look like? And can all these components be reloaded within a reasonable amount of time? None of that depends on this. But that's only one step. And yeah, what comes next in terms of dry run testing might be, yeah.
Yes, but like I'm kind of thinking that we should also like start embracing, let's say, configuration aspect on staging of like adding new database, even it's not used and yet, and test different scenarios when like this database go nuts or anything like that, how application gonna behave. So I think right now we have actually probably 2 or 3 parallel tracks from the infra side, just like what you're saying, streaming application and testing performance of the failover. Second track is really like just embracing configuration aspect and like adding new database that's maybe not used for anything useful to actually check how applications gonna behave in the scenarios that like I don't know, this, let's say, database restart or whatever, or like it shutdowns, what harm it's gonna cause to application, but also like monitoring aspect. And okay, these are 2. I don't see like third one yet. And third one probably gonna be later, which is actually what you were mentioning is, can we redirect reads for the CI into new database cluster, but it's gonna come later.
I think like the things we're working on are all consistent with that, but you're right that the second step is just going to be blocked by having support in cloud native and Omnibus, because we can't get on staging without that, right? And if that's what if you want to test in staging what GitLab looks like when it connects to 2 different databases, and we talked about that with the CI instance variables table, maybe that's how we want to test that behavior, then yes, that we need to make it so that they can be configured. I don't think GitLab, the application, needs to really do much else now for them to start on that, though, because we have.
No, I don't think so. I think with the track number 2, what we also need to embrace is like just deployment resiliency of adding new tables, migrating data on these new databases and things like that. This is something that we need to also like see if it works properly on staging. So with the track number 2, I think like this configuration aspect becomes important to embrace, like that application can function with this database, can properly configure pooling size. It's actually like we have a template to configuring this new databases everywhere, which is like, I don't know, runbooks, chef, whatever else you use that. And the next step on this track would be like ensure that we can migrate and roll back on this new database changes to this database. Because like as soon as we start moving more data, more tables, more migrations, it's gonna be pretty important step.
I think then we just won't be able to do any of that until the support's added to Omnibus and Cloud Native GitLab. So there's already discussing whether they can bring that forward. But if not, then I think we just want to figure out if we're actually going to work on that, or if we just say, okay, that's going to delay it and we're waiting. We can try to take it on ourselves. Will that really help if they're going to have to review it? I don't know. Those probably need to speak to people who actually develop it though, because I have no idea.
Yes, I have no idea either. I'm just kind of like noticed this morning that it's scheduled pretty late into the future, and I think we need this slightly earlier than that. I mean, it would definitely help.
Yeah, I agree. It definitely help. Especially if you're going to do a readiness review and all that kind of things. It's definitely something that the infra will ask for.
There's one thing.
Yeah, sorry.
There's one little point. With this other approach that we are using stream replication and cut the traffic and redirect to this new cluster, if we need to roll back this to one cluster, we will be in a really, let's say, delicate and painful process, okay?
Yeah, I wrote down like the different options we would have for disaster recovery in that situation, because there's multiple scenarios, and I wanted to document the different scenarios. One is that you'd try to fail over and no writes make it through because the new cluster actually just blocks writes, and in which case, well, you just change the connection back because there's no data that's inconsistent. This scenario where writes have gone across, well, you potentially have data loss. But yeah, we can document what we would actually do as the steps to reverse the situation and minimize that's part of the plan at the bottom of it, just this disaster recovery stuff. But if there's better ideas about disaster recovery or better changes we could make to reduce risk, then we should document those too.
Yes, rollback of two databases into one, it's gonna be a tricky problem to solve.
There's also the possibility that we could, like, build tooling that if writes were actually happening to the second one, we had to roll back because of performance reasons, we could actually replay the WAL files. If we hadn't lost them, the WAL files would be backed up to somewhere. We could rewrite a logical decoder that actually finds all the CI updates and replace those against the other database. That's depending on our risk tolerance and what we actually think are likely things to go wrong. We could recover from that as well.
I'm kind of have maybe like an open question to you, Jose, and this doesn't have yet issue. It kind of came out right now in my head. What are other tools not related to GitLab application that depend on a single database? I mean, I don't know, for monitoring, for alerting, for any kind of metrics, anything that would be broken when we disconnect into two databases, anything that you see from the infrastructure side that would need to also be addressed.
Yeah, you're right. Like starting for monitoring, because like our monitoring doesn't see this cluster at the moment. We need to add all the monitoring that we have inside of Prometheus, Thanos. Besides, we need to go for Elk as well, like all the logging that we are sending there. And we need to create like, let's say a standardized setup for infrastructure for new databases, because like today CI, tomorrow can be users or any other split that we will do on the shard that we will do in our database. So yeah, we need to take care of all of it. Like it's not planned at the moment. But you're right. Like
Yes.
monitoring stop. Yeah.
Yes, because like I think like we know about some of them, like GitLab exporter. I think we know about some Grafana dashboards, but the question is like how we can like discover that better, like what would be broken, or like what components we should inspect if they would be broken in the changes that we are making. So maybe like first would be like listing things that may be affected, and then like we could go one by one together on figuring out if this is actually affected or not.
Makes sense. I will list what I think about and add everyone to the thread, and we start to think about it. But good point.
Because like wait, I'm asking, I know that like, for example, some of the CI runner queries, they were executed in the past directly on the database to fetch some data. So I'm just kind of curious that we likely have more of such everywhere.
I have a question for you. How you see the use of Sidekick for this if we break in two databases? You will have some Sidekick applications that will connect to the CI/CD database, or how would you explain this?
Can you like be more specific on question?
Okay, how how a Sidekick will use the CI/CD database? Like, do we gather information from CI/CD from Sidekick, I guess?
Like Sidekick is part of the GitLab race. The same, like it's one of the components, another component being web. So it would work exactly the same as everything else.
Okay, let me tell you why I'm raising this. Because in .com, we have a specific PG Bouncer pool just for Sidekick and one other PG Bouncer pool specific for Web API. And I think this is slightly different from the Omnibus.
But this is only like the configuration aspect. I don't know the history of that. I'm just assuming that we are hitting physical limits of maintaining many connections to the PG Bouncer. That's why we split that into two PG Bouncer to redirect our side key and all the rest to the separate PG Bouncer. But it's still like functionally for the application, it's still like the same, let's say, connection, same logical database. It's like using different hosts because of the amount of the nodes that we are running. So I think it's more like that we are hitting like physical limits of how many connections we can efficiently handle given amount of the nodes. So I'm kind of assuming that this is something that we would have to replicate as well in this model, because we're gonna be effectively doubling amount of the connections that is coming from the application. So then my question is gonna be like, is having twice amount of the connections from each node be a problem or not? I assume that it's not gonna be a problem, but this is something also like to look at.
It won't be a problem for the number of connections you have to the database. The only thing I want to tell you here is like our PG Bouncer configuration for these two nodes, for these two clusters are different, okay? One of them use transaction mode, and for Sidekick, we use session mode. The reason why we did this delta, this difference, I'm not aware. I need to investigate as well.
Yeah, I think that probably dictates whether or not we need to replicate that again is why it's there for, but yeah, it likely will be exactly the same. The workloads that you're talking about that cause problems in production to begin with were probably CI workloads because they run in web and Sidekick, and that's one of our biggest workloads anyway.
I'm kind of thinking also that like one of the reasons why maybe using session versus transaction is about longevity of the connections and like type of the work that you execute. Like on the web, you usually have very short executions that you can really like, you read data from anything that is available. So it's like not sticky, and like you don't care if you read that from, let's say, another connection or something. Where in the Sidekick, this is usually a long-running thing that you kind of require consistency across execution. So I'm kind of thinking this is more like that. optimization for the web fleet that can be like less, sorry, that can be more permissive in the way how you execute, and it kind of allows you more random access pattern. Where side key, I think I may be completely wrong, but side key kind of requires more, let's say, a long living approach where you kind of have much better consistency. But you also keep the connections for longer as well on the side key. And I know that it caused some challenges in the past with idle transaction being for quite long, where like it's not present on web. But it's actually pretty good that you are mentioning that, because it also affects how we can reconfigure the current connection based on, like, say, let's say schema search path. I know that, Tonk, you look at that actually. So in the PG bouncer, it means like whatever you execute can be like treated as a self-sufficient query, like an isolated query that can kind of be executed on any connection that is available on the other end of the PG bouncer, where it's going to behave differently across web and POM and side key because of the different PG bouncer configuration. So this is something to keep in mind on testing the behavior.
Mm-hmm. Yeah, what I can confirm as well is like the sessions in Sidekick are longer, of course. For this, we have a higher saturation metric, but doesn't mean that it's always being used all the time. The resource is allocated, but sometimes you have even idle on it. But just sharing this point.
So I think we're gonna need to replicate exactly what we have right now in the production, in the CI model. So I don't think that we can do it differently unless we kind of fully understand all the design decisions made in the past to make this split. Okay, I think that's it for today.
Okay.
Thank you very much.
Bye.
Thank you. Have a good day.
Thank you. Bye.